Good day and welcome to Big Bad Tech. I'm your instructor, Jim Pytel, and today's topic of discussion is unit conversion. Our objective is to learn to convert quantities to different units of measurement. Imagine the joy you'd feel having washed ashore alive after a particularly brutal shipwreck. Similarly, imagine the revulsion you'd feel upon realizing you've washed upon the shores of an isolated and stubborn society that does not use the metric system. Luckily, such a situation is unlikely to occur, since only a small minority of backwards countries do not use the metric system. On the remote chance you ever deal with these savages, you must learn to convert their archaic and unwieldy measurements into metric or other usable equivalents. There exist several different methods of unit conversion. Among them, 1. Look it up on the internet. This method is admittedly super easy, but sometimes the internet isn't available. 2. Use a conversion factor. I don't recommend this method because it necessitates a user memorize long strings of number. And 3. Probably the easiest way to convert between one system units to another is to multiply that quantity you wish to convert by 1. Allow me to demonstrate. Some of you might be under the impression that there is only one, but that is far from the truth. There in fact exist infinite flavors of 1. For example, 1 over 1 could rightly be called 1, as could 2 over 2, 10 over 10, or following this line of thought, 312 over 312, or elephant over elephant. Long story short, you can make a 1 out of anything divided by itself. As long as that thing above the fraction line, i.e. the numerator, is equal to that thing below it, i.e. the denominator, you have yourself a 1. We can use this fact to our advantage when performing unit conversion. You're no doubt aware that 12 eggs are considered 1 dozen. 1 dozen is 12 eggs, and 12 eggs are 1 dozen. These are two equal quantities. If in fact these two terms represent equal quantities, we can make a 1 using two different systems of units. Consider the ratio 1 dozen over 12 eggs. If 1 dozen is 12 eggs, and 12 eggs are 1 dozen, this is a 1. If we wanted to convert a given quantity of eggs into an equivalent amount of dozens, one could multiply the quantity of eggs by 1, where 1 is chosen to be 1 dozen over 12 eggs. The unit I want, dozens, is on top. The unit I don't want, eggs, is on the bottom. Consider a giant pile of 552 eggs. Let's say we want to know how many dozen egg cartons we need to pack this pile of eggs into for shipment to the store. Multiply by 1. 552 eggs times 1 dozen over 12 eggs. Units of eggs cancel out, and we're left with 46 dozen. This method also works in reverse. Consider the ratio 12 eggs over 1 dozen. If 1 dozen is 12 eggs, and 12 eggs are 1 dozen, this is also a 1. If we wanted to convert a given quantity of dozens into an equivalent amount of individual eggs, one could multiply this quantity of dozens by 1, where 1 is chosen to be 12 eggs over 1 dozen. The units I want, eggs, is on top. The unit I don't want, dozens, is on the bottom. Let's say we wanted to know how many individual eggs are inside 72 dozen. Multiply by 1. 72 dozen times 12 eggs over 1 dozen. Units of dozens cancel out, and we're left with 864 individual eggs. This is a very easy trick as long as you stay organized. The conversion ratio must be arranged such that the units you want are on top and the units you don't want are on the bottom. The units you don't want should cancel out and the units you want should remain. Let's try a couple illustrated examples using this method. Consider two different means of measuring power: the time rate expenditure or production of energy, the watt and the horsepower. 746 watts is equivalent to 1 horsepower. We'll examine power and energy in greater detail in later lectures. Right now, we just want to be able to convert between these two systems of units. Let's say you hop in your buddy's 60 horsepower boat for a day of gator hunting. At peak power output of 60 horsepower, what is the equivalent power output of the boat in watts? The unit you want is watts. The unit we don't want is horsepower. The one we need to multiply is 746 watts over 1 horsepower. 60 horsepower times 746 watts over 1 horsepower. Units of horsepower cancel out, and we're left with 44,760 watts. If we express this number in proper engineering format, it would be written as 44.76 kilowatts. If we're asked to round this to the nearest tenth place, we could say 60 horsepower is roughly equivalent to 44.8 kilowatts. Let's try this method in reverse. Consider a motor capable of exerting 186.5 watts of output in the loaded condition. Let's say we want to know this motor's equivalent output in units of horsepower. The unit we want is horsepower. The unit we don't want is watts. The one we need to multiply by is 1 horsepower over 746 watts. 186.5 watts times 1 horsepower over 746 watts. Units of watts cancel out, and we're left with 0.25 horsepower. Now, before you rush off and express this answer in proper engineering format as 250 millihorsepower, let me explain something to you that you might or might not be aware of. You'd think every system of units would use engineering prefixes to make expressing unusually large and usually small numbers in a compact, readable format, but that is most assuredly not the case. Units like horsepower, brasses, barns, board feet, barrels, hectares, hogsheads, hours, minutes, seconds, inches, feet, miles, fathoms, furlongs, gallons, and grains don't use engineering prefixes and are written as regular numbers. Remember those? Regardless of how small or big they are. 0.25 horsepower would be represented as plain old 0.25 horsepower. More than likely, it'll be expressed as the fractional equivalent of a quarter horsepower. Now, I don't like this foolishness any more than you, but I will reluctantly admit that it does have its uses. First, it's a sanity check on our conversion. If 1 horsepower is 746 watts, it stands to conjecture 186.5 watts will be less than 1 horsepower, or some smaller fraction than 1. In fact, that's what motors less than 1 horsepower are called, fractional motors, i.e. something smaller, or a fraction of 1 horsepower. Motors having an output of 1/4 horsepower, as in our example, 1/3, a half, or 3/4 horsepower would all be considered fractional horsepower motors. In contrast, integral horsepower motors are motors that have an output of 1 horsepower or greater. For example, 2, 5, or 10 horsepower motors would be considered integral motors. Also, the unit of horsepower is a great indication of safety. Think about it. Can a horse kill you? You're damn right a horse can kill you. A horse could smash you to a bloody pulp. Be extremely careful when you're working on actuators greater than 1 horsepower or 746 watts. Returning to our example, could a quarter of a horse kill you? Like, could a kick from one leg of a 4-legged horse kill you? Yes, it could, depending on where you get hit. Be careful when you're working with quarter horsepower motors. In fact, be careful of any device capable of exerting power in any portion of your anatomy you wish to keep in working order. Moving on. While we're dealing with horsepower and watts, let's discuss multi-step unit conversion. As you are no doubt aware, 1 horsepower equals 746 watts. 1 horsepower also happens to equal 550 foot-pounds force per second in the U.S. customary system of units. Given a 186.5 watt motor, or a quarter horsepower motor, how much output in units of foot-pounds force per second can it produce? We're presented with 2 options, both of which should yield the same result. Option 1, 2-step conversion. First step, convert watts to horsepower. As we previously demonstrated, 186.5 watts times 1 horsepower over 746 watts, units of watts cancel out, units of horsepower remain, yields 0.25 horsepower. Step 2, convert units of horsepower to foot-pounds force per second. The unit we want is foot-pounds force per second. The unit we don't want is horsepower. 0.25 horsepower times 550 foot-pounds force per second over 1 horsepower, units of horsepower cancel out, and units of foot-pounds force per second remain, yields 137.5 foot-pounds force per second. Option 2, single-step conversion. If 1 horsepower is 746 watts, and 1 horsepower is also equal to 550 foot-pounds force per second, it stands to conjecture 746 watts is equal to 550 foot-pounds force per second. Using this equality, we can cut out the intermediate conversion to horsepower. The unit we want is foot-pounds force per second. The unit we don't want is watts. 186.5 watts times 550 foot-pounds force per second over 746 watts. Units of watts cancel out, and units of foot-pounds force per second remain, similarly yielding 137.5 foot-pounds force per second. Use whatever method you wish, as long as you get the correct answer. Before we test ourselves with some illustrated examples, I want to show you how I'm performing unit conversion on the TI-89 in exponential format engineering. Since some of the systems do use engineering prefixes, and some don't, you might struggle interpreting results unless you remember this simple fact. While in exponential format engineering, the TI-89 expresses every number in engineering format, regardless of what format you feed it. If your chosen system of units uses engineering prefixes, just take what the calculator gives you. If your chosen system of units does not use engineering prefixes, you got to convert the answer back into the base unit. Allow me to demonstrate. Consider our first example. We were asked to convert 60 horsepower to watts. Watts uses engineering prefixes. 60 times 746 yields 44.76 E3 on the TI-89. E3 is the prefix kilo, so this is 44.76 kilowatts. Again, if we were asked to round this to the tenths place, it'd be roughly 44.8 kilowatts. Let's say we're being asked to convert this to an equivalent amount of foot-pounds force per second. Foot-pounds force per second do not use engineering prefixes, so we're going to have to convert the calculator's answer back into the base units. Your choice: horsepower to foot-pounds force per second or watts to foot-pounds force per second. Either method should yield the same result. I'm going to convert watts to foot-pounds force per second. The unit we want is foot-pounds force per second. The units we don't want is watts. 550 foot-pounds force per second over 746 watts is 1. Enter 44.76 EE3, or better yet, use the previous results. This will save you from re-entering data. Notice you got to use the unrounded entry 44.76 E3, not the rounded answer 44.8 E3. You must use the complete unrounded entry for the most accurate results. Multiply this by 550, divided by 746. Press enter. The calculator says 33 E3. If foot-pounds force per second employed engineering prefixes, you'd use a kilo prefix, but they don't, so we need to convert this back to the base unit. 33 E3 means 33 times 10 to the third, or 33 times 1,000, so our output expressed in the base units of foot-pounds force per second is regular old 33,000 foot-pounds force per second. Dig? I think the hardest thing for folks new to this game is determining which units use engineering prefixes and which ones don't. This will take some time and exposure. For now, don't worry about it because I'm going to tell you when it's appropriate to apply engineering prefixes and when it isn't. In the spirit, let's move on to some illustrated examples. Given these quantities, see if you can convert them to a desired system of units. To aid us in this task, we've been given the following equivalencies. Power. 746 watts is equal to 1 horsepower, which is equal to 550 foot-pounds force per second. Watts uses engineering prefixes, whereas horsepower and foot-pounds force per second don't. Pressure. 1 bar is equal to 100 kilopascals, which is equal to 14.5 psi. Both bar and pascals use engineering prefixes, whereas psi's don't. Volume. 1 gallon equals 231 cubic inches. Neither of these units use engineering prefixes. Time. 1 day equals 24 hours, 1 hour equals 60 minutes, and 1 minute equals 60 seconds. None of these units use engineering prefixes. Angle. 2 pi radians equals 360 degrees. Neither of these units use engineering prefixes. And finally, length. 1 inch equals 2.54 centimeters. Inches do not use engineering prefixes. It might be worth a moment of your time to copy these conversions down on your cheat sheet because one day this material may or may not show up on a quiz. Hint, hint. A brief explanation about centimeters. Despite their popularity, centimeters aren't really official engineering units. 1 centimeter is 1/100th of a meter, or 1 times 10 to the negative 2 meters. If we use proper engineering format, 2.54 centimeters would be expressed as 25.4 millimeters, which is a proper engineering prefix. So you can add this additional quantity to our equivalencies, such that 1 inch equals 2.54 centimeters, which happens to equal 25.4 millimeters. If you had to enter units of centimeters into your calculator, you'd enter it as EE-2. If the calculator is in exponential format engineering as requested, it will automatically reformat it to proper engineering format, of which centimeters is not an option. It's up to you to do the conversion back to centimeters. I should also note that people unnecessarily freak out about angular measurement conversion using units of radians and degrees, so a little explanation might be necessary. Consider a circle with radius of length r. The perimeter of the circle, i.e. the circumference or outside, has a length of 2 pi times r, regardless of the length of the radius, be it 1 meter or 1 mile. For example, a circle with a radius of 1 meter has a circumference of 2 pi meters, or roughly 6.28 meters. Whereas a circle with a radius of 1 mile has a circumference of 2 pi miles, or roughly 6.28 miles. How far you travel around that circumference is respective of the angle. For example, if one traveled pi radians, or 3.14 radians, one would have walked halfway around the circle, or 180 degrees. If, however, one only traveled pi over 2 radians, or roughly 1.57 radians around the circle, one would have walked quarter of the way around the circle, or 90 degrees. Long story short, pi is just a number. 3.1415, blah, 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 and 2 pi is roughly 6.28. Don't get confused by the fancy pi symbol. It's just a number. To get the most accurate conversion, remember to use the most complete representation of pi available in your calculator by using the second pi key. All right, I do believe we're prepared for liftoff. Let's put your understanding of this unit conversion concept to the test. Convert these quantities to the desired system of units. By all means, pause the lecture and try this yourself. If you're tracking, you should have obtained the following results. Our first couple of problems deal with power conversion. We're first being asked to convert 1.5 megawatts to units of horsepower. The unit we want, horsepower, is on top. Units of watts cancel out. We're left with roughly 2,010.7 horsepower. We're next asked to convert 1.5 megawatts to an equivalent amount of foot-pounds force per second. Let's do a single-step conversion bypassing the horsepower intermediary. The unit we want, foot-pounds force per second, is on top. The unit we don't want, watts, is on the bottom. Units of watts cancel out. 1.5 megawatts times 550 foot-pounds force per second divided by 746 watts yields 1,105,898.1 foot-pounds force per second. Again, foot-pounds force per second do not use engineering prefixes, so you're stuck with this rather large ungainly number. Our next problem is asking us to convert 50 horsepower to an equivalent amount of watts. The unit we want, watts, is on top. The unit we don't want, horsepower, is in the bottom. 50 horsepower times 746 watts per horsepower. Units of horsepower cancel out. We're left with 37,300 watts, or more appropriately, 37.3 kilowatts. We've additionally been asked to convert 50 horsepower to an equivalent amount of foot-pounds force per second. Let's do a two-step conversion. We've already got our value in watts, so let's convert watts into foot-pounds force per second. The unit we want, foot-pounds force per second, is on top. The unit we don't want, watts, is on the bottom. 37.3 kilowatts times 550 foot-pounds force per second divided by 746 watts. Units of watts cancel out, and we're left with 27,500 foot-pounds force per second. Our next set of problems deal with pressure, where 1 bar is equal to 100 kilopascals, which equals 14.5 psi. Units of bars and pascals use engineering prefixes, whereas psi does not. We're first being asked to convert 90 psi to bar. The unit we want, bar, is on top. The unit we don't want, psi, is in the bottom. 90 psi times 1 bar divided by 14.5 psi. Units of psi cancel out. We're left with 6.2 bar. Next, we're being asked to convert 90 psi to an equivalent amount of pascals. Let's do a single-step conversion. The unit we want, pascals, is on top. The unit we don't want, psi, is in the bottom. 90 psi times 100 kilopascals divided by 14.5 psi. Units of psi cancel out. We're left with 620.7 kilopascals. Our next illustrated example is asking us to convert 230 kilopascals to bar. The unit we want, bar, is on top. The unit we don't want, pascals, is on the bottom. 230 kilopascals times 1 bar divided by 100 kilopascals. Units of pascals cancel out, and we're left with 2.3 bar. We're then asked to convert 230 kilopascals to an equivalent amount of psi. Let's do a two-step conversion. Taking our previous answer of 2.3 bar, we need to convert this to psi. Psi is the unit we want, so that's on the top. We don't want units of bars, so that's in the bottom. 2.3 bar times 14.5 psi over 1 bar, units of bar cancel out, we're left with 33.4 psi. Next, we're being asked to convert 70 bar to pascals. The unit we want, pascals, is on top. The unit we don't want, bars, is on the bottom. 70 bars times 100 kilopascals divided by 1 bar, unit of bar cancels out, we're left with 7,000 kilopascals. Using proper engineering format, this is more appropriately expressed as 7 megapascals. We're next asked to convert this number to an equivalent amount of psi. Let's go ahead and again do a two-step conversion and convert 7 megapascals to an equivalent amount of psi. The unit we want, psi, is on top. The unit we don't want, pascals, is on the bottom. 7 megapascals times 14.5 psi divided by 100 kilopascals. Units of pascals cancel out. We're left with 1,015 psi. Our next set of illustrated example problems deal with volume and time. We've first been asked to convert 190 cubic inches to gallons. The unit we want, gallons, is on top. The unit we don't want, cubic inches, is on the bottom. 190 cubic inches times 1 gallon divided by 231 cubic inches. Units of cubic inches cancel out. We're left with 0.8255 gallons, or rounded to the nearest 10th place, roughly 0.8 gallons. Next, we're being asked to convert 5 gallons into cubic inches. The unit we want, cubic inches, is on top. The unit we don't want, gallons, is on the bottom. 5 gallons times 231 cubic inches per gallon, units of gallons cancel out, we're left with 1,155 cubic inches. Next, we're being asked to convert 11 weeks into an equivalent amount of seconds. This is designed to test your understanding of multi-step unit conversions. First, convert weeks to days, days to hours, hours to minutes, and then minutes to seconds. 11 weeks is equivalent to 77 days. 77 days is equivalent to 1,848 hours. 1,848 hours is equivalent to 110,880 minutes. We're left with 6,652,800 seconds. Our last set of illustrated examples deal with angle and length. We've first been asked to convert pi over 6 radians to units of degrees. Pi over 6 radians are roughly equivalent to 0.5236 radians. The unit we want, degrees, is on top. Units we don't want, radians, is on the bottom. 0.5236 radians times 360 degrees divided by 2 pi radians, units of radians cancel out, we're left with 30 degrees. Next, we're being asked to convert 45 degrees to an equivalent amount of radians. The unit we want, radians, is on top. The unit we don't want, degrees, is on the bottom. 45 degrees times 2 pi radians divided by 360 degrees, units of degrees cancel out, and we're left with roughly 0.7854 radians, which, if you think about it, is a quarter radian. Next, we're being asked to convert 40 centimeters into inches. The unit we want, inches, is on top. The unit we don't want, centimeters, is on the bottom. 40 centimeters times 1 inch divided by 2.54 centimeters, units of centimeters cancel out, we're left with roughly 15.7 inches. Lastly, we've been asked to convert 72 inches to centimeters. The unit we want, centimeters, is on top, and the unit we don't want, inches, is on the bottom. 72 inches times 2.5 centimeters divided by 1 inch, units of inches cancel out, and we're left with roughly 182.8 centimeters. All right, hopefully those illustrated examples went well for you. If not, I'm encouraging you to rewind or revisit this lecture and correct any mistakes you may have made. In conclusion, this lecture took a look at unit conversion. Remember to review this material as often as you need to really drive it home. Imagine how well lab will go if you know what you're doing. Thank you very much for your attention and interest. We'll see you again during the next lecture of our series. Remember to tell your Lazy Lab partner about this resource and be sure to check out the Big Bad Tech channel for additional resources and updates.